Right, year 10s, welcome to the second video, well, the lockdown video, whatever you want to call it. Right, I got a request for help on two questions. One was about circle theorems and the other was about simultaneous equations. So I'll go through the circle theorems one first, which is quite straightforward actually. So what you've got is a circle theorem called the alternate segment theorem, and it's quite an easy one to deal with, but spotting it is a bit tricky sometimes. But in the question that we've got, it's actually easy to spot as well. So I'll go through what the theorem is, and then we'll see how we use it to answer the question. Right, so let's say we've got a circle, and on that circle, we're just touching that circle, we draw a tangent. So a tangent is just a line that touches a circle. Now it doesn't have to be horizontal, it can be at any angle. I've just drawn it horizontal. And where the tangent touches the circle, that's your first point of a triangle that you're going to draw inside the circle. So I'm just going to draw a random triangle. So 1, 2, 3. So there's my triangle. And what the alternate segment theorem says is that this angle over here is the same as this angle here, and also this angle over here is the same as this angle over here. Okay. Now, in addition to this, there is something else we're going to need to know, and that is identifying an isosceles triangle. So an isosceles triangle can be identified in two different ways. Now you'll see I've not drawn this to scale, which doesn't matter. As long as you put the symbols on it, that's the main thing. What it says is, if these two sides are the same, then these two angles must be the same. Okay, that's an isosceles triangle for you. But it also works the other way around. Okay, so if you were to told that these two angles are the same, then that would mean these two sides are the same. And that's how we're going to be using the facts about an isosceles triangle to actually help us solve our problems. Okay, so let's just move this over here and get the question up, which is here. And let's just read through the question. Now, it is a bit complicated, but once you break it down, it's not too bad. Right, so it says A, B, and C are points in a circle, such that BC, that's this line here, okay, that line bisects angle ABQ. So bisects this whole angle that I've just marked here. Okay. Now, if it bisects that angle, that means it cuts it in half. Now, we've already got half that angle over here, which means the other half must be the same. So if that's called X, then this must be X. Okay, so this has nothing to do with the alternate segment theorem yet. I'm just saying that this line is halved this angle. Okay, so that you can label this one X as well in this case. Then we can use our alternate segment theorem, which says that this angle over here is the same as this angle over here. Okay, which means this must also be X. And then from there, we can use what we know about isosceles triangles, which says if you've got a triangle with two angles which are the same, that means these two sides must also be the same. So AC must be equal to BC, which is what we're trying to show. So although it looks like a complicated question, it's not too bad as long as you're willing to practice recognizing the circle theorems and you know which one to use. Okay, so let's just move on to the second question. Right, so this second question is about simultaneous equations, and it involves ratios, so it makes it a little bit more complicated. But before we do the question, I'm just going to go over one or two things. Okay, but let's just see the question in the first place. Okay, this is the question, and it's about the price of some radios in a particular ratio, and as one thing increases, so as they both increase, the ratio changes, and when they're reduced by a certain amount, the ratio changes again. And what we've got to do is work out what the ratio was in the first place. But before we do that, let's just do some basics on ratios. Okay, so let's just say I've got two numbers, and those are x and y. Or no, actually, let's just say a and b because we've got x and y in the question. Okay, and we're told the ratio is 1 to 2. And if I want an equation that relates, or sorry, a formula or an equation that relates a and b, you might think, well, okay, a equals 2b, and you know it wouldn't be unreasonable for you to write that. You know, it's an easy mistake to make, but you can see that a, which is this number, is not 2 times b, which would be this number. Okay, 1 is not 2 times 2. In fact, it's the other way around. Okay, 2a equals b is the correct equation. Okay, so 2 times a is equal to 1 times b. So 2 times 1 is equal to b. 2 times 1 is 2, and 2 is what b is. Okay, so just remember that. And if I had two other numbers, so c to d, if I said the ratio was 3 to 7, I would write 7c equals 3d. Okay, so just bear that in mind. The number that goes with the letter is the one on the other side of the ratio. Okay, so let's just get rid of that and let's get on with the question. So the tough part of this question is not the actual simultaneous equation bit itself, it's actually getting to the right equation. So let's just look at what we've got. Okay, when both prices are increased by £20, so x plus 20 and y plus 20, the ratio becomes 5 to 2. Okay, so I want to change this into an equation. So remember, I need to multiply this side by 2 and this side by 5. So 2 times x plus 20 equals 5 times y plus 20. And let's expand these. So 2x plus 40 equals 5y plus 100. And let's just tidy this up a little bit. So I'm going to take away 5y from both sides to move it over here. So 2x minus 5y equals, and if I subtract 40 from both sides, this is meant to be 100, not 600, that becomes 60. So that's my first equation. I'm just going to write it over here. So 2x take away 5y equals 60. Oops, 60. And that's my first equation. Now I'm going to rub all this out because I want you to be able to see all my working, but obviously in an exam situation, don't do that. Okay, keep your working there. Right, so let's have a look at what the next bit says. When they're reduced by £5, the ratio becomes 5 to 1. So x take away 5 and y take away 5, and the ratio there is 5 to 1. So x minus 5 is equal to 5 times y minus 5. Let's expand and simplify just like before. X take away 5 equals 5, y take away 25. And let's just move things around to make it the same as this. So if I take 5y off both sides, that becomes x take away 5y. And if I add 5 to both sides, that becomes minus 20. So that's my second equation. So x minus 5y equals minus 20. So that's equation number 2. And again, I'm just going to get rid of this because that's where I'm going to put my working. Right, so you've got two simultaneous equations, and what makes them easy is the fact that you've got 5y in both of them, so you just either need to add or subtract, but because they're both negative, we just need to subtract. But we have got some other negative numbers, so we just need to be a bit more careful. Right, so let's have a look. What would we do? In this case, we need to subtract, so let's just do 1 take away 2. So equation 1 take away equation 2. So 2x take away x is just x. The minus 5y take away minus 5y, that'll cancel it out. And then I've got 60 take away minus 20. So you'd add, to take away minus 20, you'd add it. So you get x equals 80. So that's x. Then I'm going to sub that into the second equation. Okay, because it's just easier than the first equation. So x take away 5y. So 80 take away 5y equals minus 20. And let's just add 5y to both sides. So 80 is equal to minus 20 plus 5y. And let's add 20 to both sides. So this becomes 100 equals 5y, which means y is 20. Divide by 5 to get 20. So y is 20. So that's the second part. So the final answer that we need, it says, look, write the ratio x to y in its lowest terms. So x is 80, y is 20. So 80 to 20. And I can divide them both by 20 to get 4 to 1. Okay, and you can go back and check these answers if you need to. The way to do it would be to plug in those prices, 80 and 20, increase them by £20, so you get 100 and you get 40, okay, and then simplify that ratio, which does give you 5 to 2, and reduce them by £5, so you get 75 and 15, which simplifies to 5 to 1. So we know the answer is correct. So I hope that's helped, and I'll look out for some of the common errors and misconceptions, and I'll try to put them right in the next video. Okay, see you next time.